Hello guys, in this video I'm going to solve this problem and I'm going to explain how to sketch parametric equations. So first, if you're given this parametric equation, the first approach is try to eliminate the parameter. Why? Because we want to find the Cartesian one. So what I'm going to do, I'm going to take x is equal to 4 cosine theta, y is equal to 5 sine theta, and divide both sides by coefficient 4 and 5 correspondingly. And then I'm going to raise both sides to the second power. And we remember that cosine squared theta plus sine squared theta is equal to 1. So what we can do, we can take right now those two equations, add them up, and what I'm going to obtain is that x squared over 4 squared plus y squared over 5 squared is going to be equal to 1. So you can see when you have like cosine and sine theta, you always can use a trick to find the Cartesian equation. So finally, what do we have? We have that original parametric equation we're going to rewrite in this Cartesian equation, which is x squared over 4 squared plus y squared over 5 squared. In other words, we just finished step 1 for sketching parametric equation. For step 2, what do we need to do? Right now we need to take that Cartesian form of our parametric equation and sketch it using like dashed lines. So you can see that our Cartesian equation is actually going to be the equation of an ellipse. And if you want to find the equation of an ellipse, what do you need to do? You need to find the intersection with x-axis and y-axis. So I can find the intersection with x-axis because y is equal to 0. So that's why I know that x squared is equal to 16. Or in other words, x is equal to plus minus 4. And the same way I can find the intersection with y-axis. I said x is equal to 0, and then I will find that y is going to be equal plus minus 5. And then if I have all these 4 points, I can just connect them by these dashed lines. So in other words, I'm going to obtain the Cartesian graph of parametric equation. As our final step, what do we need to do? Right now we need to sketch our parametric equation if we have the Cartesian one. So to sketch the parametric equation, we need to know what is our initial point for parametric graph, ending point, and then by knowing those 2 points, we're going to indicate the direction. So initial point, if you have your bounds for t, then you just take your first value of t, which is t is equal to negative pi over 2, and plug into your parametric equation. So you can see how I'm doing computation for x and y in that case. And your ending point, it's the last value of t. So it's for that value of t when you're going to evaluate your parametric equation. So you can see actually I found 2 points, 0, negative 5, and 0 and 5. But the problem is here, when I have these 2 points, I have 2 possible approaches how I can approach my parametric graph. So which one do I need to choose? So to answer that question, what do we need to do? We need to find some point in the middle. What do I mean by point in the middle? We need to take some t, for example, when t is equal to 0. And then you're going to plug in this t into your parametric equation, and you will figure out either you're going to get some point on the left-hand side of the y-axis or on the right-hand side of the y-axis. So let's actually compute what is our values for x and y when t is going to be equal to 0. So x of 0, since cosine of 0 is 1, then x is going to be equal to 4. And since sine of 0 is 0, then y is equal to 0. So you can see I got point 4 and 0. So that means that I'm going to be left only with the right branch of my ellipse. So this is going to be the parametric graph. So parametric graph is some finite like subgraph, or like let's say this is a subgraph of Cartesian graph, where you're going to indicate your initial point, which is in this case t is equal to negative pi over 2. You're going to indicate your final point, t is equal to pi over 2, and then you connect and then you show the direction, the arrow from the initial point to the final point. Okay, thank you for watching this video. If you're not subscribed to my channel, please subscribe and have a nice day. Bye.